Welcome back to Algebra 2, Chapter 9, Section 1 in this book. So this is something I taught you already in Algebra 1 if you had me, and maybe even pre-algebra, but it is inverse and direct or joint variation. Now, I always say the math teachers try on this one, bless their hearts, but science is the way to understand this. So I always start with science, okay? So I run. I'm a runner. Started running when I was in middle school and never quit. Still at it. And I run slow, but I'm still running. So my usual run is I go a 5K, which is a little over 3 miles, in about 30 minutes. I told you it's slow. I'm not winning any awards. But I'm out there a couple of times a week doing my 3 miles, even in the hot summer. So if you see me over at the courthouse track, you'll see me puttering around. So speed equals distance over time. So imagine one morning I'm feeling very good and I decide to run 4 miles in my usual time. Will my speed have gone up or down? It would have gone up. For me to do 4 miles in the usual time is faster. What if one day, not feeling it, and instead of taking me 30 minutes, I did my 5K, my 3 miles, in 40 minutes? Would I be going faster or slower? I'd be going slower, right? So it is because speed and distance are both in the numerator. They vary directly. If one goes up, the other one goes up. If one goes down, the other one goes down. If my distance goes down in the same time, I've slowed down. If my distance goes up in the same time, I've sped up. Speed and time, one's in the numerator and one's in the denominator, so they vary inversely. Meaning if I do the same distance but my time goes up, my speed goes down. If I do the same distance but my time goes down, I do it faster, then that means my speed goes up. They're opposite because one's in the numerator and one's in the denominator. Now this is what math does with it. They make an equation. Of course they do. They're math. They say y equals a constant times x if it's direct. Notice it's all in numerator land. And if it's inverse, then I wrote that one wrong. If it's inverse, then the constant's on top and x is in the denominator. So this is like, so one's in the numerator land, one's in denominator land. If one goes up, the other one goes down. They work inversely. All right, so we're going to say, are x and y inverse or direct or joint? So they're both in numerator land, so what are they? They are, I'm going to call it direct. They're directly related. They're both in numerator land. Are they direct? No. Because for direct, it has to be multiplying, not adding, so this is neither. No. How about this one? Well, here we have x and y next to each other. It looks like they're both in numerator land, but you have to have one on one side of the equal and the other one on the other side. So if we move this over by dividing both sides by x, we can see it's inverse, that it fits the inverse model. Okay, how about these? This is how they normally give you the problem. They will tell you x and y vary either inversely, directly, or jointly. They'll use one of those words. So you know which formula to write down. Then what do? You sing, substitute, and you substitute in 8 for y and 3 for x. Now we're going to solve for a k, but y is k not known as being divided by 3. So what's the opposite? Multiply by 3. What we do to one side, we do to the other. So, doop, doop. So 3 times 8 is 24, k equals 24. But that's not the answer to your problem. Then they want you to go back and rewrite the formula, but put 24 instead of k. That's the answer that they usually have you do for part A. Then they'll say, well, what about if x equals -4? Then we use this formula we've made, we sing substitute and put in -4 for x. 24 divided by -4 is -6. Okay, so what about if there's a z? Do you think these vary inversely or directly? Well, it's all direct. because they're all in numerator land. Z varies directly with X and Z varies directly with Y. How about this one? Notice it's in denominator land, so Y varies inversely with the square of X. So it's inverse with, I'll say, with X squared. It doesn't really invert, so you have to include the squared. How about here? Z varies directly with Y, Z varies inversely with X. So in one problem you might have part inversely, part directly. Alright, so that's really an easy problem though. Come back and we'll do something a little more fun. We're going to graph some fancy functions. Math is great.